Hey folks, from NetPlay Studios, I'm Chris McDougall, and this is Brew Jam TV. And in today's episode, we're going to convert this Marshall fridge into a Kegerator, complete with a beer tower and 2 taps for dispensing our homebrewed beer. In this first video, we're going to take a look at the modifications we're going to have to make to the inside of the fridge, as well as the installation of the beer tower itself. And then in the next video, we're going to take a look at the setup of our kegging system and filling them up with beer for the first time. If you like what you see, make sure you like and subscribe and hit that notification button to get notified when the next video comes out. Before we get started, I just wanted to give a quick shout out to our sponsor for this video, beergrains.com. Beergrains.com was kind enough to provide all of the equipment we're going to need to transform this fridge into a Kegerator. I'll be placing links in the description for all the products that we use in the video. If you have any questions, you can check them out at beergrains.com. Let's take a look at this Marshall fridge that we're going to be using to convert into a Kegerator. Okay, so here's the fridge we're starting with. It's the 4.4 cubic foot Black Edition Marshall fridge. I've had my eye on this thing for a while. I always thought it would make a good Kegerator. If only I could manage to squeeze some kegs into it. We don't really have the space at home for a keezer that would hold 4 or 5 kegs, so this is the next best thing, and of course looks much cooler. You can pick these up at marshallfridge.ca here in Canada, marshallfridge.com in the US. If you want to learn more about the fridge itself, I did a full review that's on my channel that I started before I tore the fridge apart. I'll try to remember to put the link right here. Okay, so let's get started. So because we need to make a big hole in the top of this thing, we need to first figure out where the coolant lines are running. One way to do that is to use the evaporation technique. So what we did was mixed up a quick mixture of alcohol and cornstarch. Alcohol, in this case we use vodka because rubbing alcohol is impossible to find at the time of filming. By brushing it on a thin coat and watching, you're supposed to be able to see the outline of the cooling lines where it evaporates first. I tried this twice to no avail before contacting the manufacturer and learning that there are no coolant lines at the top of the fridge. So we're okay to move to the next step. Here's an exploded view of the fridge that they told me I could share. You'll notice that there's no coolant lines going through the top of the fridge with the exception of this one that goes across the back, connecting the left and right sides. Now this is the 3.2 cubic foot version of the fridge, and you'll notice it doesn't have an evaporator shelf. This version of the fridge doesn't have the chiller, and so instead of the evaporator shelf, it has this plate with coolant lines running through it that's placed at the rear of the fridge. But apart from that, I'm told that in terms of the coolant lines, these two fridges use the same layout. With that out of the way, we can start ripping this apart, starting with the doors, just a couple bolts, and then there's the freezer door that has 2 pins that if you bend it just the right way, you can get it out. And then after taking out the screws that hold it in place and moving the control panel out of the way, to get the height that we need for the kegs to fit, we need to fold the evaporator shelf 90 degrees so that it sits flush against the back of the fridge, which involves bending this coolant line and trying not to get it too kinked in the process. Now this is something that I definitely could have done better. The space is really limited back there, but if I were to do it over again, I would put something round inside the bend to try and keep the shape of the pipe as much as possible as I was bending it. I've seen some fridges where this is only a 90-degree bend that has to happen. Because the pipe essentially has to bend 180 degrees, it's really difficult to do. It ended up way flatter than I would have liked, and it's going to bother me every time I open up the fridge. But as long as it ends up working, I'll be happy. So now that we have the height that we need, it's time to get the width. Since the kegs don't quite fit side by side, we're going to have to cut out these shelf supports. Now it would have been much better to have done this before I bent down the evaporator shelf, but as they say, hindsight is 20/20. Had I cut this plastic after I bent down the evaporator shelf, I could have gone all the way to the back of the fridge. As it stands, there's going to be a couple inches of shelf that I simply can't get out of there, and it just would have been cleaner overall. It also would have made for a much easier time covering this up, but we'll get to that in a bit. But I'm not done making mistakes yet. Here's another one. I know that there are coolant lines in the side of the fridge, so I'm taking great care when I'm cutting off these supports that protrude from the side. But what I didn't expect to find were wires running through the actual support itself. Now at this point I thought I was super lucky for having somehow missed those wires in there with my X-Acto knife, but as I would find out later, we were going to have some electrical issues. But I wasn't going to find that out until much later. And so after test fitting, we can see that even with the shelf supports cut out to take full advantage of the full width of the cavity, the right-hand keg is still about 2 inches proud of where it needs to be. So because the width of the 2 kegs is wider than the inner diameter of the fridge, the kegs are staggered in such a way that the left keg sits all the way at the back of the cavity right up against the compressor hump. And this is a rounded edge, so if we can cut out enough material at the bottom for the back of the keg to sit flush up against the compressor hump, we'll be in better shape to get the door closed. Since the surface isn't really flat, the X-Acto isn't much use here, and we're back to cutting the plastic with the Dremel tool and hoping like heck that there isn't anything important back there to hit. Luckily, the only thing that ended up being behind the plastic in this area was more foam, which ended up getting cut out with the X-Acto knife. And with another test fit, we can see that there's still a gap of about a centimeter between the keg and the compressor hump. And with a second keg test fitted, our keg is now protruding about 2 centimeters at the bottom and maybe about 4 centimeters at the top from where the door will need to sit. So it's time to cut out one last chunk of the plastic bulkhead to close that last little bit of gap. With another test fit now, we can see that space is going to be tight inside our fridge. It's also pretty clear at this point that we've robbed as much space as we can, or at least as much space as I'm comfortable with robbing from the bulkhead up against the compressor hump. And it's time to turn our attention towards the door. The rubber gasket pops right out and gets set aside for now. Here's a close-up of the channel in which it sits. We want to leave all this intact while we're cutting out the door panel with an X-Acto knife. Thankfully, because of the way it's molded, there's a nice inside corner to keep our line straight with the X-Acto knife. And then I used first a chisel and then a crowbar to pry the front of the door off of the rest of it. And so yes, we are sacrificing a little bit of insulation for this, but it's really the only way to get the kegs in, so I'm not too concerned about it. Next, we need to see where the kegs are going to foul on the door when it's closed. So what I did was I put some spray wax on one of the kegs, the one that protrudes, and then put the door up against it, and where the door made contact with the keg, you could see it. So in those 3 places, those correspond with these 3 waxy parts on the door, and I know where I need to cut away in the insulation to get the keg not to foul on the door. So I started with making a line, and then I made another 2 lines, and these are basically just guides for me to come in with the X-Acto knife and basically just kind of carve out a semicircle, but you know, it's more kind of angular because I'm using a straight blade. But in a perfect world, I guess it would have been a semicircle that corresponded with the round edge of the keg. Cutting that thing away with the X-Acto knife, it's pretty easy to do, and then I'm basically respraying with wax again to get an idea of whether it still fouls, and it doesn't. Looks like we're actually good now. So after cleaning up a bit, I needed to turn my attention to sealing where I had cut away the shelf supports on the side of the fridge. Ended up using black duct tape, didn't like it, replaced it later, but for now that's what we're going with. Got the evaporator shelf mounted in with just a couple screws, self-tapping screws. And then it was time for a test fit with all of it. Then it was back to the door. So I laid out the door flat, took off the seal that goes around the outside, and cut some aluminum foil to length. Used some spray adhesive just to get that stuck down to the foam. Reasonably flat. I wanted to use something that would really get into the inside curve of where I'd cut away. And this did a pretty good job. Again, I used some of that black duct tape. Ended up replacing that later with aluminum foil tape, but that we're pretty good for now. And then it was time to get the hinge back on of the door. And another test fit, this time with the tank. Everything fits fine, so it's time to look at where to put this controller unit. And that's got the temperature control as well as the temperature probe that sticks out of it. It's also got the light, the built-in light for the inside of the fridge. No good place to put that, so I turned my attention to this manifold that just so happened that the mounting holes perfectly corresponded with these holes that I had in the evaporator shelf. So a couple of very small bolts in there, and that mounted up nice. I would end up having to do a little bit of adjustment to that later, but for now I was pretty content with it. The only place to put that control unit that I was talking about just a second ago looked to be on the top left of the fridge. That was only the only place where I had some extra room. So what I needed to do was make a bracket to mount it to, because I didn't want to mount it directly to or cut any holes into the side of the fridge because I was afraid I might hit some gas lines. So I cut away some of the shelf just with an X-Acto knife, and then went back with the ended up using the bottom of the shelf actually, but with an X-Acto knife to start. Didn't work that well, so I went back to the trusty Dremel, cut that thing out of there, and then the idea was I was going to stand this off from the side of the fridge, just with a couple of the existing screw holes that were already in the side of the fridge, so I knew that those wouldn't hit any gas lines, or at least I hope so. So by mounting that to where you can see some of those holes there, I could mount the control panel on top of it, and then it wouldn't have to sit inside, because it's not meant to mount flush onto a flush surface. There's a little recess in the mold on the other side of the fridge where it had come from that accepted one of the bulkier side, which had the light on it. So once I had that all in place, it was a matter of cutting out enough of the material that I could mount up the control panel to it, and there's things like the light that would need to protrude through had enough space that it could sit flush on the top of that bracket and look okay. And this, of course, meant that I would have to extend basically all the wires that went to that thing all the way across the back of the fridge and into where the new location is, where it's going to live from now on. So cleaning that up a bit with the flapper wheel and the drill press, and then doing another test fit. It's looking okay. Need to remove more and more material. It's kind of difficult to work with. It's a matter of, you know, getting it all mounted up and then testing it, moving it, testing it, cutting away a little bit more at a time, making sure that the keg still fits in under, because there's literally millimeters there. Okay, so now it's time to do some wiring work. Got out some, ended up doing this originally with some connectors, some butt connectors that I had the mind that I might want to undo some of this later. If I needed to take out some wires, I wanted to be able to do so. So I did it the first time without any soldering, just with a couple butt connectors, basically taking each of the wires and extending them. So putting a connector on the existing cable, putting one on the other end, so on and so forth, just so I could get those 5 or 6 wires. Need to use some pretty decent wires on this because it is passing 120 volts and some pretty decent amperage, at least for the compressor, through some of these wires. So use a decent gauge. There's not quite as much current going through the wires that are for the light, but I wanted to use at least as thick or thicker as what was there already. So once I had that all kind of banged out, while I still had this thing out, I wanted to make a little template for a door to cover on the other side where the thing used to live. So I did that by just tracing the outline of it onto some black plastic that I had taken from the door panel that we cut out, the old door panel. Then put some heat shrink around that. I'm not going to shrink it up just yet, but use another piece of a heat shrink just to make it easier to fish the wires through. And then testing it again, plugging it in and testing it. I noticed that the light was a little bit dimmer than I had remembered, but I kept soldering on because it worked for now. Just took some black plastic loom and covered all the wires to make it look uniform, so I didn't want to see any bare wires in the fridge. And then once I had made the connections, I tucked them all into the cavity where the control panel used to live. Then I decided to make a quick cardboard template for this cavity before I cut the black plastic to at least have a fighting chance of getting something similar to the shape that I needed. Cut it first out of paper and then out of cardboard, and then I ended up deciding to scrap the black plastic entirely in case I wanted to use that for something else. Didn't end up using it, but it's going to get covered anyway, so this piece of melamine countertop that I had lying around ended up being the cavity cover. So I had that taped up, get cleaned up again, and then it's going to be time to test it. This time with the tank. I'm going to install everything, get it all the kegs put back in, turn it on. Just kidding. Those switches don't do anything. But I got to clean up, and now it's time for the really stressful part. Okay, so now we have to drill for the tower, and this is the part that I was least looking forward to in all the build. So I made a little X to mark what was the center of the top of the fridge, and then by using the gasket, I was able to put 4 little holes. By lining them up with the lines of my X, I was pretty sure that was going to be centered. So I started out with a really small drill bit and went all the way through the top layer of metal, through the foam in between, and then the layer of plastic in underneath. And then using that as a guide, I used the hole saw, but I didn't go all the way through. I just cut the top layer with the hole saw and then went underneath and did the same thing from the bottom. And by doing that, I minimized the chance of having tear outs. And it ended up lining up not quite perfectly, but close enough, and you're not going to see this from the outside. Now I can actually put the tower in. I couldn't before because of the way that the lines already go through it. And I just double checked that my holes were in the right spot, and used the punch to give the drill bit something to dig into. Drilled the full holes for that, and then I had to go to the hardware store and get some of these flanged bolts. Ended up not using the washers on the top, but used the washers on the bottom. So just 4 bolts and 4 nuts, and ended up using 4 washers as well. One thing I wanted to do beforehand, and I actually, while I was at the hardware store, I bought some aluminum tape that I ended up using pretty extensively throughout the rest of the build, and actually going back and getting rid of some of the black duct tape. I wanted to seal it off, so I sealed everything with the aluminum tape, top and bottom, inside and out, and then installed the tower, this time with the gasket, and it's going to stay on there pretty much permanently. And use these 4 pretty large washers. It's not super sturdy to be using just nuts on the inside of that plastic sheet, because it's just a flat plastic sheet. It's not terribly thick. So I used the big washers to spread out some of the load so that it wouldn't, create a huge dimple and basically compress the heck out of that surface. And then another test fit, this time with the tower, the lines, the kegs, got the control unit, the manifold, and the tank in there. Pretty much everything, and I was definitely a happy camper. And this is before I had tested it off camera and found that I was having some intermittent electrical problems. I didn't quite know the cause yet. I tested all the wires for continuity off camera and everything seemed fine, but the problem was intermittent, so I figured maybe it was in the connectors that I had used. So I ended up undoing it, removing all those connectors, hard soldered each of the original wires to my extension wires, covered them up with heat shrink, and then put them back in the cavity. And when I plugged it in and tested it again, it worked just fine. So I was pretty happy with myself at that point. I said, cool, diagnosed and found the problem. Not quite. I tucked all the wires back up in the cavity, and just after doing so, found the root of the issue. So you remember that wire that I was sure that I hadn't cut at the beginning? Turns out I had. I sliced clean through it. Not only that, but I could already tell that there was at least one other wire that I'd cut with the X-Acto knife, and it was in a spot that it was going to be really, really difficult to try to, get enough of that wire out of there so that I could solder into it. But I had no choice at this point. The only other alternative would be running entirely new wires, figuring out basically what connected to what, and making new holes in the thing. I didn't want to do that, so I kind of did it the easy way, so to speak, which was to try to get enough of that wire poking out that I could solder a tiny extension onto it to repair what I'd messed up. So there were 2 wires, maybe 3, that I needed to do this to, so it was basically a question of, yeah, that's the 3rd one there. I ended up there was enough of that one that I was pretty sure that it was just the shielding that was cut, or at least that's what it looked like. So I was basically just going to hope for now that that's okay. And thankfully, after some time, I was able to dig up enough of that wire that I was very carefully able to strip enough of the insulation off of it, using heat, using an X-Acto, using whatever I could, because my strippers wouldn't fit in there too well. But eventually I got enough that I could get my soldering iron in there, get a little bit of solder on it, insert a tiny little extension, put on a tiny bit of heat shrink, enough that I could properly insulate the wires. Remember, this is 110 volts that's going through this, so I really don't want to mess this up and have it start arcing inside the cabinet and burn my house down. But the heat shrink ended up not fitting, so I used electrical tape and basically just wrapped it around with a pair of pliers as much as I could so that it was good enough. So there's a tiny little extension there, and then plugging it in, turning on the power bar, and I see the LED light up. So at that point I was pretty relieved. And it's much brighter than it was before. Oh, and I replaced the door switch with this on-off type switch. Otherwise it would have been on all the time, because we basically cut away the part of the door that used to come into contact with the switch when the door was closed, so it would have stayed on all the time. For now at least, the electrical work was done. And so now, since this was the first time that I had the fridge all the way back together since I kinked that refrigerant line, bending the evaporator shelf in the beginning, I needed to make sure that it still worked as a fridge. Now I was a bit concerned because on the warmest setting, which is 1, 0 is off, 1 is the warmest setting on the controller, I was getting all the way down to 2 degrees Celsius, so just above freezing. And the last thing I wanted was frozen beer. But I was able to keep the kegs in there overnight, and the lowest it got down to was 2 degrees Celsius. Beer freezes at about -2, so I figured we were okay. I'd ripped off the black duct tape at this point. It was time to use the magic of YouTube to, oh, didn't work the first time? How many times you get a snap? Jeez. I'm not sure that's how it's supposed to work. Anyways, I replaced all that black tape with nice, shiny aluminum tape. And the reason I'd use black is because I hoped it would kind of disappear into the side of the fridge, and that didn't work. But this tape makes a much better seal. And the other thing I'd noticed in my tests is that the black tape, with the humidity, was starting to basically peel off after only about a day of use. So the aluminum tape is holding up just fine, and that's a big improvement over what was there. It's more visible, but hey, you never see it when the door's shut anyway, so I was not too concerned about that. So this is what the interior of the fridge ended up looking like just before I'd installed all my fittings to get the kegs in there. And I'm pretty happy with it. Once again, I'd like to thank BeerGrains.com for working with us to put out this video. They provided all of the kegging equipment we needed, including the kegs, tank regulator, tower, taps, beer lines, everything we needed for our conversion, they had it in stock. They're a family-owned business and have super friendly, knowledgeable, bilingual staff on hand to help you out with your next homebrew project. Enormous selection of grains, hops, yeast. They have a fantastic selection of all of it, and they allow you to buy grains in bulk. Just a great homebrew shop in general. They have a fantastic, very robust website. They were an absolute pleasure to work with and a pleasure to shop with, whether you're just getting started in homebrewing or you want to turn your Marshall fridge into a kegerator and need a complete keg draft system for homebrew to do it. So again, huge shout out to beergrains.com. You guys are awesome. All right, folks, that's going to be just about all we have time for in this video. If you haven't already, please like, comment, and subscribe. Thank you for watching. Stay tuned for the next video where we're going to set up the kegs and fill this up with beer for the first time. Cheers.